All right, so I'm going to review some factoring greatest common factor problems here. So number one, remember we're looking for the biggest number that divides evenly into 16 and 4. So that biggest number is 4. So I'm going to write GCF colon 4. So 4 is the biggest number that divides into both of those terms. And then they both have a variable of a p, but the smaller exponent of the two is p to the third. So remember, that's the trick for looking for the GCF of variables. All right, and then we've got to figure out what is left in this problem after we factor out a 4p to the third. So remember, we're just doing reverse multiplication here, doing reverse distributive property. We divide here. 16 divided by 4 is 4. P to the fourth divided by p to the third is p to the first. And then the second division problem, you're dividing 4p to the third by itself. Of course, if you divide anything by itself, you get 1. So this is your answer. The 4p to the third is the greatest common factor. The 4p plus 1 is what's left over. Super easy to check. Do the distributive property. 4 times 4 is 16. P to the third times p is p to the fourth. 4p to the third times 1 is just 4p to the third. And you can see that matches the original problem. So I erase all that. So we're just doing reverse multiplication when we do these problems. Let's look at a couple more. Same thing on number 5, find the greatest common factor. So obviously the two numbers are both -6. So I'm going to factor out a -6. That's the biggest number that goes into -6. Remember, if the lead number is negative, which it is in this case, that tells us we have to factor out a negative number instead of a positive number. So it's all about the lead number being negative or not. And then variable-wise, they both have an r, but the smaller exponent is r to the fourth. So that's what we're going to factor out in this problem. So we need to divide the first term and the last term by -6 r to the fourth. So this first term, the -6's are going to cancel. R to the fifth divided by r to the fourth is r. When you divide variables, you subtract the exponents. And then same thing here. Anything divided by itself is 1. Only time we have to write a 1 is when everything cancels out. Like a lot of times we don't write the 1 that is in front of that r, even though we could. All right, let's look at just a couple more. Number 9. So we need to find the GCF of -28. So first thing I notice is that lead number is negative. So that tells me I'm going to factor out a negative something. All three of these numbers are divisible by 2. So we could factor out a 2, but that's not the greatest common factor. The greatest common factor is -4. That is the biggest number that divides evenly into all three of those coefficients. And then you'll notice they don't all three have a variable. Only the first two terms have a variable, so you can't factor out a greatest common factor. So we're going to divide all three terms by just a -4. So that's going to give us a +7 v squared. -8 divided by -4 is going to be a +2 v. And -36 divided by -4 is a +9. Let's look at one more problem. Let's look at number 11. So number 11, again, they don't all three have a variable. That's the first thing I notice. So the greatest common factor in this problem is just going to be a number. It's going to be a positive number because the way the problem is written, that lead coefficient is a positive 20. So the GCF in this problem, the biggest number that goes into 20, negative 35, and negative 20 is 5. So we're going to divide all three of these terms by the greatest common factor of 5, and we're going to get 4 minus 7n squared minus 4 n to the third.